Hello there, and welcome to Sleepy Planet Show. I am so glad you have found your way to this quiet corner of the cosmos tonight. Perhaps you have had a long and challenging day, and you are seeking a soft place for your mind to land. Or perhaps you are simply someone who finds a deeper comfort in the vast, silent mysteries of the universe than in the familiar act of counting sheep. Whatever has brought you here, you are in the right place. There is nothing left for you to do but to rest. Allow your body to settle into a state of profound ease. Let your breathing slow and deepen, each exhale carrying away a little more of the day's tension. Feel your muscles soften, your limbs grow heavy and light at the same time, as if gravity itself has decided to loosen its hold on you just for a little while. Tonight, we are not merely stargazing from a distance. We are embarking on a gentle, drifting journey through our very own home galaxy, the Milky Way. Imagine yourself floating, weightless and serene, through a vast, shimmering spiral of stars, dust, and mysterious, unseen forces. This celestial city, our home, has been turning slowly and gracefully in the deep silence of space for over 13 billion years. It is a place of breathtaking beauty, a river of light that has captivated human hearts for as long as we have looked up at the night sky. But beneath this familiar, comforting beauty, the Milky Way holds deep and wondrous secrets. We will drift through its spiral arms, past rogue stars flung violently from its core, and through invisible forces that hold the entire structure together. We will encounter ancient stellar remains that defy our understanding of how galaxies form and grow. Our journey tonight will take us gently from the bright, bustling neighborhoods of the galaxy's spiral arms to its secretive, hidden core, where a supermassive black hole sleeps. We will witness the echoes of colossal collisions with other galaxies and listen to the silent stories of stars that are older than the Milky Way itself. You will hear of stellar nurseries, vast and beautiful clouds where new suns are born, and you will come to understand the strange, unfinished story of a galaxy that is still growing, still evolving, still becoming. Some of the facts you hear tonight may surprise you. Others may simply spark a quiet sense of curiosity, a gentle what if that you can hold on to as you drift deeper and deeper into sleep. And just before we begin our celestial voyage, if you find that these calm, curious explorations help you to unwind or offer a peaceful way to end your day, please consider leaving a gentle like on this video and subscribing to the channel. It is a small, quiet gesture that helps other sleepy souls find their way to this sanctuary, one traveler at a time. Now, let the world outside fade away. Let the darkness behind your closed eyes become the vast, open canvas of space. Our journey is about to begin. Chapter 1. A Galaxy of Collisions and Immigrants. Our Milky Way may feel like a serene and stable home, a constant, unchanging river of stars in our night sky. But this image of tranquility is an illusion born of our own fleeting timescale. The truth, written in the motion of stars and the faint, ghostly streams of light that wrap around our galaxy, is that the Milky Way is a dynamic and often violent place. It is a cosmic cannibal, a grand structure built from the wreckage of countless smaller galaxies it has consumed over billions of years. Its serene beauty is the beauty of a survivor, a galaxy stitched together from the remains of others. Over the vast, deep course of cosmic history, the Milky Way's immense gravity has acted as a relentless lure. Smaller, dwarf galaxies, wandering too close, have been caught in its gravitational embrace. Once captured, they are slowly and methodically pulled apart. Their stars are unraveled from their orbits and stretched into long, graceful arcs of light known as tidal streams. These ghostly ribbons of stars, some containing millions of suns, still wrap around our galaxy today, the faint celestial scars of ancient mergers. They are the quiet, beautiful evidence of the Milky Way's tumultuous past. One such cosmic meal is happening right now. The Sagittarius dwarf spheroidal galaxy, a small companion to our own, is currently being pulled apart as it passes through the Milky Way's disk. Its stars are being siphoned away, creating a vast stream that encircles our galaxy. We are witnessing in slow motion the death of one galaxy and the growth of another.
And this process is not over. As you lie here, drifting towards sleep, another, much larger encounter is slowly unfolding. Far off in the night sky, so distant that it appears as a faint, fuzzy smudge of light, is the Andromeda Galaxy. It is a great spiral, much like our own, containing perhaps 1 trillion stars. And it is moving steadily, inexorably, towards us. In about 4.5 billion years, the Milky Way and Andromeda will meet in a cosmic collision of unimaginable scale. It will not be a collision of explosions and shattering stars, as you might imagine. The distances between individual stars are so vast that it is incredibly unlikely any two will ever actually hit each other. Instead, it will be a gravitational dance of breathtaking elegance and complexity. As the two galaxies pass through each other, their immense gravity will warp and distort their beautiful spiral shapes. Long, graceful tails of stars and gas will be flung outwards into space, creating vast, curling arcs. The two supermassive black holes at their centers will begin a slow, spiraling dance, eventually merging into one even larger black hole. After billions of years of these gravitational interactions, the two galaxies will settle, their stars mingling together to form a single, colossal elliptical galaxy, a new, quieter, and more rounded form. The beautiful spirals we know today will be gone, folded into a new beginning. Even galaxies, it seems, are not eternal. They grow, they evolve, they collide, and they are reborn. The galaxy you're resting in tonight is a living, breathing structure, shaped by a long and dramatic history of cosmic encounters. Even more fascinating is the idea that some of the stars in our Milky Way are not native to it. They are ancient immigrants, older than the galaxy itself. Not every star you might see in the night sky was born here. In the vast, spherical halo that surrounds our galaxy's bright disk, there are ancient, wandering stars that move in long, tilted orbits. These stars are what astronomers call metal poor. In astronomical terms, a metal is any element heavier than hydrogen and helium. The very first stars in the universe were made almost exclusively of these two lightest elements, as the heavier ones had not yet been forged in the hearts of stars and scattered through supernova explosions. The ancient halo stars we see today have almost no heavy elements. Their chemical fingerprints show that they were born in a much earlier, more pristine era of the cosmos, very shortly after the Big Bang. Astronomers believe that these stars did not form within the Milky Way, but originated in smaller, primordial galaxies, ancient building blocks that merged to form our own galaxy billions of years ago. These stars move slowly, high above and below the galactic plane, like elder spirits from a time before grand spirals, before order had fully taken shape. In their faint, ancient light, we are looking at a piece of a universe that was younger, wilder, and still learning how to become what it is today. They are quiet, living fossils, reminders that our galaxy is not a single, pure creation, but a beautiful and complex mosaic, assembled from the light of 1,000 other long-forgotten worlds. Chapter 2: The Grand Silent Motion. As you rest here, in the quiet of your room, it may feel as though you are perfectly still, but this stillness is a beautiful illusion. You are, in fact, on a journey of incredible speed and unimaginable scale, a silent, sweeping motion through the cosmos. Every part of our existence is in motion. The Earth is spinning on its axis. The Moon is circling the Earth. And the entire solar system, our Sun with its family of planets, is hurtling through the galaxy at a speed that is almost beyond comprehension. Our solar system orbits the center of the Milky Way at over 828,000 kilometers per hour. That is more than 230 kilometers every single second. It is a speed so immense that you could travel from one side of the Earth to the other in less than 3 minutes. And yet, the Milky Way is so vast, so colossally large, that even at this incredible velocity, It takes our solar system approximately 225 to 250 million years to complete just one single loop around the galactic center. This immense span of time is known as a galactic year. It is the slow, majestic heartbeat of our cosmic neighborhood. To put this into perspective, since our solar system first formed about 4.6 billion years ago, we have only completed this journey around the galaxy about 20 times. All of human history, from the first hominids to the present day, has taken a tiny fraction of a single galactic year. When the first dinosaurs appeared on Earth, our solar system was in a completely different part of the galaxy, on the other side of the spiral. The stars we see in our night sky today were not always our neighbors, and they will not remain so forever. The constellations that our ancestors knew will, over vast stretches of time, slowly drift apart and form new patterns. Everything is in motion. Quietly, slowly, endlessly. As you sleep tonight, remember this grand, silent dance. You are not just resting in a bed. You are a passenger on a planet that is spinning, orbiting a star that is itself sweeping through a vast, turning city of stars. You are part of the galaxy's motion, a quiet participant in its long, winding story. And this story is not yet finished. Our galaxy, though ancient, is still growing. It is not a static, completed structure, but a work in progress. Even now, it continues to gather material from the space around it. It pulls in vast, cool clouds of gas from the intergalactic medium, the tenuous space between galaxies. It captures and consumes smaller dwarf galaxies, as we have seen, adding their stars to its own halo and disk. And it accretes streams of the mysterious dark matter, the invisible scaffolding that holds the entire structure together. It grows not like a living thing with a conscious purpose, but like a great gravitational structure, its well of influence deepening over time. Some of this growth happens quietly through the gentle infalling of gas clouds that will one day fuel the birth of new stars. Other times, the growth is more disruptive. As satellite galaxies are torn apart, their stars scattered across the sky in beautiful, ghostly streams. The galaxy you live in today is not the same one the dinosaurs saw. It is larger, more massive, and chemically enriched by generations of stars. And the galaxy that our distant descendants may one day know could be larger still, stitched together from the ruins of 1,000 smaller worlds, its spiral arms slowly and gracefully changing shape over the eons. We are living in just one chapter of a very, very long book. One of the most surprising things about our home is that we are not even sure of its basic shape. It seems like something we should know, a simple question. How many arms does the Milky Way's spiral have? But because we are located deep Inside the galaxy's disk, it is incredibly difficult to see the whole structure. It is like trying to map the shape of a forest while standing in the middle of it. Thick, dark clouds of interstellar dust obscure our view of distant regions, hiding entire sections of the galaxy behind a cosmic veil. Stars, from our perspective, blur into one another, making it difficult to trace the clean, elegant lines of the spiral arms. For decades, astronomers believed that the Milky Way had 4 major spiral arms, but more recent and sophisticated observations, particularly from infrared telescopes that can peer through the dust, have suggested a different picture. Some studies now suggest there may be only 2 dominant arms that spring from the central bar of the galaxy, with the other 2 being less significant minor arms or spurs. Other evidence indicates that the arms may twist and split in ways that are far more complex and fragmented than we expected. Some arms may fade away into faint wisps of stars, while others may wrap around the galaxy in unexpected ways. The Milky Way may not be the neat, perfect pinwheel we often see in illustrations. It is likely a more organic, messy, and wondrously complex swirl of stars and gas, its shape sculpted by a long history of mergers and gravitational interactions. Our inability to see our own home clearly is a beautiful and humbling reminder of our place within it. We are part of the mystery, looking out from the inside. Chapter 3: The Galaxy's Hidden Violence and Silent Structures. While the overall motion of the Milky Way is a slow, graceful turning, its heart and its hidden corners are home to moments of breathtaking violence and strange, silent structures that speak of a more chaotic nature. Most of the billion stars in our galaxy drift calmly in their orbits, following the predictable paths laid out by gravity. But a rare and special few are outcasts, flung from their homes at astonishing speeds, fast enough to escape the pull of the Milky Way entirely. These are hypervelocity stars. Imagine a star not drifting, but hurtling through the dark at over 1,000,000 kilometers per hour, a glowing cannonball shot into the vast, empty space between galaxies. Astronomers believe that some of these rogue stars are the remnants of binary star systems, 2 stars orbiting each other that wandered too close to the supermassive black hole at the center of our galaxy.
As the binary system approached the black hole, its immense gravity would have captured one of the stars, pulling it into a final doomed orbit before it vanished forever beyond the event horizon. In this gravitational exchange, the other star would have been catapulted outward, flung with incredible force like a stone from a slingshot. These rogue stars travel alone, far from the bright plane of the galaxy, like glowing comets with no path of return. They are silent, luminous reminders that even in a galaxy bound by gravity, there are moments of violent release, quiet, powerful expulsions that send entire suns flying into the intergalactic night. And while some stars orbit in predictable, orderly paths, others defy the rules entirely. Most of the stars in the Milky Way's disk orbit the galactic center in the same general direction, following the grand, sweeping rotation of the spiral. But not all of them do. Some stars, particularly in the ancient diffuse halo, move in retrograde orbits. They travel backward against the main flow of galactic traffic. These backward orbiting stars are almost certainly immigrants. They were likely born in smaller dwarf galaxies that were later captured and absorbed by the Milky Way. As their home galaxy was torn apart, these stars were integrated into our own, but they retained the memory of their original motion. Their reversed orbit is a quiet gravitational signature of their foreign origin. It is as if the galaxy carries old memories in its very motion. The stories of ancient mergers and cosmic encounters preserved not in light or in matter, but in the slow, patient turning of a few rebellious stars against the stream. The sheer number of these past encounters is staggering. Astronomers now believe that the Milky Way may have eaten dozens of dwarf galaxies over its long lifetime. These were not grand, dramatic collisions like the one we expect with Andromeda, but slow, quiet acts of consumption. Small, faint galaxies, our luminous companions in the local group, would have drifted too close, been caught in the Milky Way's gravitational tide, and slowly been dismantled over hundreds of millions of years. Their stars are now part of our own galaxy's halo, or its thick disk, or they form the beautiful, ghostly stellar streams that we can still map today. Astronomers can identify these past mergers by carefully analyzing the motion, age, and chemical composition of stars. One particularly large event, known as the Gaia-Enceladus merger, which happened billions of years ago, is thought to have added many stars to our halo and may have fundamentally reshaped the early structure of the Milky Way. Our galaxy, it turns out, is not a pristine, self-contained spiral. It is a composite, a hybrid, a beautiful structure stitched together from the quiet, luminous ruins of many smaller, forgotten worlds. This galactic archaeology is possible because every star carries a unique chemical fingerprint, a pattern of elements imprinted in its atmosphere at the moment of its birth. By capturing a star's light and passing it through a prism-like instrument called a spectrograph, astronomers can see this fingerprint, a spectrum of light with dark lines that correspond to specific elements. Some stars are rich in heavy elements like iron and calcium, which tells us that they formed in dense, metal-rich regions from gas that had already been enriched by previous generations of stars. Other stars, particularly the ancient ones in the halo, are nearly pure hydrogen and helium.
These metal-poor stars were born when the universe was still young, before many supernovae had had a chance to forge and scatter the heavier elements. These chemical differences allow scientists to group stars into families, to trace their origins back to specific star-forming clouds, or even to specific captured galaxies. This technique, known as stellar spectroscopy, allows us to reconstruct the hidden story of the Milky Way's formation, one star at a time. In this way, chemistry becomes a kind of time machine, allowing us to read a star's deep past like a line of ancient poetry written in the beautiful and silent language of light. And what we read in that light are the stories of those shredded galaxies. Across the sky, if you know how to look, you can see their remains. Thin, almost invisible ribbons of stars stretch in vast, graceful arcs and curves. These are the stellar streams we spoke of, the final, beautiful remnants of smaller galaxies and star clusters that wandered too close to the Milky Way and were pulled apart.
As these structures orbit our galaxy, their stars are smeared across space by tidal forces, forming long, delicate trails that trace their former paths. Some of these streams wrap around the galaxy like ghostly halos. Others dive in towards the core, weaving through the disk. These streams are the most direct and haunting evidence of past collisions, the quiet, gravitational mergers that built the Milky Way over billions of years. The galaxy, like a great and ancient tree, carries the rings of its past not in wood, but in every shimmering, delicate thread of starlight. We have explored its violent past and its grand, sweeping motions. Now we will venture deeper into the subtle architecture and the invisible forces that shape its form, the hidden structures that give our galaxy its unique and mysterious character. Let your mind remain soft and open, ready to receive these quiet wonders as you float ever closer to a peaceful sleep. Chapter 4: The Unseen Architecture. From our vantage point on Earth, the Milky Way appears as a flat, luminous band across the sky. But this simple view belies a far more complex and elegant three-dimensional structure. Our galaxy does not lie perfectly flat like a celestial plate. Its vast disk, hundreds of thousands of light years across, is subtly warped. Imagine a great spinning vinyl record, gently lifted up on one edge and pressed down on the other. This is the shape of our galaxy. This graceful, wave-like bend in the outer disk was completely invisible to us for centuries. It was only when radio telescopes allowed us to map the vast clouds of neutral hydrogen gas, which extend far beyond the visible stars, that this subtle warp was revealed. What could cause such a colossal structure to bend?
Astronomers believe the distortion may be the result of a long and ongoing gravitational conversation with our nearest large companions, the Magellanic Clouds. These two dwarf galaxies, orbiting our own, may be gently tugging on the Milky Way's edges, pulling the disk's delicate fabric out of perfect alignment. Or perhaps the warp is caused by interactions with a lumpy, invisible halo of dark matter, its gravitational influence bending the structure from above and below. Whatever its cause, this warp is a beautiful reminder that even a structure as immense as a galaxy is never truly still or isolated. It responds to the invisible forces around it, flexing and changing its form over eons. From a great distance, the Milky Way might look as if it is dancing, slowly and silently, through space. This leads us to the greatest and most profound mystery of our galaxy's architecture, the very foundation upon which it is built. By all the logic of the physics we can see, the Milky Way should not exist. If you were to add up the mass of all the visible matter, all the stars, the gas, the dust, you would find that there is simply not enough gravity to hold the galaxy together. The outer stars are spinning so fast that they should be flung off into the void, scattered like sparks from a spinning wheel, and yet they remain, held in their stable, graceful orbits. The answer to this cosmic conundrum is a substance that we cannot see, cannot touch, and cannot comprehend. It is called dark matter. This mysterious, invisible substance does not shine, reflect, or emit any form of light or energy. It is completely transparent to our telescopes, but it has mass, and therefore it exerts gravity, and there is an enormous amount of it. Astronomers believe that dark matter outweighs all the visible matter in our galaxy by a factor of more than 10 to 1. It is the invisible scaffolding, the vast spherical halo of unseen mass that envelops our entire galaxy and holds everything in place. We do not know what dark matter is. It could be a new type of subatomic particle, one that interacts with our familiar world only through the gentle, persistent force of gravity. But we know with near certainty that it is there. Its presence is written in the impossible speed of the stars. It is the silent, unseen majority, the quiet, gravitational soul of our galaxy. At the very heart of this vast structure, at the galaxy's dynamic and crowded center, lies its most extreme and enigmatic object. Here, surrounded by a dense swarm of ancient stars, is a supermassive black hole. It has a name, Sagittarius A star, pronounced A star. It is a singular point of gravity, a place where the fabric of space-time is stretched to its breaking point. This black hole is more than 4 million times the mass of our Sun, yet all of that mass is compressed into a region smaller than the orbit of Mercury. We cannot see it directly, of course. Its gravitational pull is so immense that nothing, not even light, can escape.
but we can see its profound effect on the stars around it. Astronomers have spent decades tracking the orbits of stars that whip around this invisible point at tremendous speeds, some completing their frantic dance in just a few years. Their paths, traced against the darkness, are the most definitive proof of the monster that lurks at the galaxy's core. For now, Sagittarius A star is mostly quiet. It is a sleeping giant. But occasionally, a cloud of gas or a stray star wanders too close and is pulled in by its gravity. As this matter is torn apart and spirals towards the event horizon, it heats up to incredible temperatures, flaring brightly with X-rays before it vanishes forever. Our galaxy's heart is a place of both quiet slumber and potential violence, a silent conductor pulling everything into a slow, relentless, and beautiful dance. The region around this central point is also strangely shaped. When astronomers mapped the core of the galaxy in infrared light, which can penetrate the obscuring dust, they discovered something unexpected. The central bulge, the dense spherical concentration of stars at the galaxy's heart, is not perfectly round. It is a three-dimensional peanut-shaped or X-shaped structure. Seen from the side, it would swell in the middle and narrow at the ends, like a great glowing hourglass made of billions of ancient stars. This strange and beautiful geometry is thought to have formed from the galaxy's central bar, a dense, elongated stripe of stars that rotates slowly like a solid object. Over billions of years, the gravitational dynamics of this bar have caused it to buckle and puff up in the middle, sculpting the surrounding stars into this peculiar three-dimensional form. We live in a beautiful spiral galaxy, but its heart is full of unexpected complexity, not flat or clean, but intricate, layered, and humming with the accumulated rhythm of billions of stellar orbits. Chapter 5: The Cradles of Creation. The beautiful sweeping spiral arms of the Milky Way are not just made of stars, they are more accurately woven from the very birthplaces of stars. They are the galaxy's great stellar nurseries, vast, dark, and beautiful clouds where new suns are constantly being born. The process of creation in our galaxy begins not in fire, but in the deepest, coldest silence. Scattered throughout the galactic disk are enormous molecular clouds, vast, dark congregations of cold gas and dust. These clouds, composed mostly of hydrogen molecules, can be truly colossal, some spanning hundreds of light years from end to end. Within their cold, dense interiors, with temperatures just a few degrees above absolute zero, the quiet and persistent force of gravity begins its slow and patient work. Small, dense regions within these clouds begin to collapse under their own weight. As the gas and dust fall inward, the clump begins to spin faster and faster, flattening into a rotating disk with a dense, hot core at its center. This core is a protostar, a star in the making.
Over hundreds of thousands of years, it continues to gather material from the surrounding disk, growing hotter and denser, until the pressure and temperature at its very heart becomes so extreme that nuclear fusion ignites. In that moment, a new star is born, and its light begins to shine out from within its dusty cocoon. These regions of intense star birth are what trace out and illuminate the galaxy's spiral arms. The arms themselves are not solid structures, but patterns of higher density, like slow-moving traffic jams that ripple through the galactic disk. As these molecular clouds drift into a spiral arm, they are compressed, and this compression triggers a new wave of star formation. The brilliant, hot, young blue stars that are born in this process are incredibly luminous, and they light up the arms, making them the most visible features of the galaxy. Every star in the sky, including our very own sun, was born in one of these cloudy, chaotic cradles long, long ago. The dust that fills these clouds is more than just a veil. It is an essential ingredient in this process. The interstellar dust, made of tiny microscopic grains of carbon, silicates, and ice, weaves through the galaxy in beautiful dark tendrils and clouds. In visible light, this dust obscures vast regions of space, blotting out the light from the stars behind it and creating dark rifts and patches in the Milky Way, like the great rift visible in the summer sky. But behind this dark curtain, creation continues. Infrared telescopes, which can detect the heat radiated by warm objects, can peer through the dust and reveal the glittering nurseries hidden within. What looks like a dark, empty patch of sky in visible light can, in the infrared, be a region blazing with the light of thousands of newborn suns. The dust, though it hides, is part of the process. It helps to shield the delicate early stages of star formation from the harsh radiation of nearby stars, and it helps the gas clouds to cool and collapse. What seems like emptiness is very often the beginning of something incredibly bright.
And yet, not every cloud of gas is destined to become a star. Across the Milky Way, astronomers have found massive, cold clouds of molecular gas that seem to have all the right ingredients for star formation, yet they remain dark and dormant. These are the starless gas clouds. Some may be too diffuse for gravity to take a firm hold. Others may be stabilized by internal magnetic fields or a gentle, churning turbulence that prevents them from collapsing. These starless clouds float through the galaxy like silent, unfulfilled possibilities. They are rich in the raw material of creation, but they are untouched by the fire of fusion. They may one day be nudged into collapse by a passing shock wave from a supernova, or they may simply drift for eons until they are torn apart by gravitational forces, their gas recycled into other regions of the galaxy. In these quiet, dark clouds, the galaxy seems to hold its breath, waiting, perhaps, for just the right moment to spark something new. This brings us to one of the most beautiful and profound truths of our galaxy. It is a great
and efficient recycler. Stars are not permanent. They live, they burn, and they die. And in their dying, they return their substance to the galaxy, enriched with new and heavier elements. When a massive star explodes as a supernova, it scatters elements like iron, oxygen, and gold into space. When a smaller star, like our Sun, reaches the end of its life, it will gently shed its outer layers as a beautiful glowing structure called a planetary nebula. This enriched material, this stardust, mixes with the existing interstellar medium. It cools, it condenses, and it eventually becomes part of the next generation of molecular clouds, the next generation of stars, the next generation of planets, and perhaps the next generation of life. Every single atom in your body, other than the hydrogen, has passed through this grand cosmic cycle. The carbon in your cells, the calcium in your bones, the iron in your blood, all of it was forged in the heart of a star that lived and died long before our Sun was ever born. The Milky Way is not a static stage for events to unfold upon. It is a great and dynamic engine of renewal. It breathes in time with its stars, making, unmaking, and gracefully, endlessly beginning again. Chapter 6: The Galactic Ecosystem. As we drift through this vast celestial city, it becomes clear that it is more than just a random collection of stars. It is a complex and interconnected system, an ecosystem on an unimaginable scale, where conditions vary dramatically from one neighborhood to the next. And just as our own planet has a habitable zone around the Sun, a region not too hot and not too cold for liquid water to exist, our galaxy may have its own version, a galactic habitable zone. This is not a sharply defined boundary, but a broad, ring-shaped region within the galactic disk where the conditions for life as we know it might be most favorable. If you get too close to the galactic center, the environment is extremely hostile. The density of stars is much higher, which increases the risk of a life-bearing planet's orbit being disturbed. The rate of supernovae is also much higher, meaning that a nearby stellar explosion could bathe a young planet in lethal radiation. And the supermassive black hole at the very core is a source of intense gravitational forces and high-energy particles. Conversely, if you travel too far out towards the sparse outer edges of the galaxy, other problems arise. These stars in this region are much more metal-poor. They have a lower abundance of the heavy elements that are necessary to form rocky planets like Earth and are the essential building blocks of life itself. Somewhere in between these two extremes lies the galactic habitable zone, a wide, comfortable band that is tens of thousands of light years across. Here, conditions are more stable. The star density is moderate. Supernovae are less frequent, and there is a rich abundance of heavy elements. Our own solar system lies comfortably within this zone, a quiet home in a vast, sprawling neighborhood where life might not be alone,
in having found a stable foothold.
The most prominent features of this neighborhood, the beautiful spiral arms, are themselves part of this dynamic ecosystem. As we have learned, the spiral arms are not fixed, solid structures. They are density waves, patterns of compression that ripple slowly through the galactic disk. They move at a different speed than the individual stars. Stars and gas clouds drift into an arm, are compressed, and then drift out again. The arm is a persistent pattern, like a slow-moving traffic jam on a cosmic highway. This has a profound consequence. Our sun, as it orbits the galaxy, does not stay within a single arm forever. It passes through them. We are currently in a smaller, minor structure called the Orion Spur, or Orion Arm, a partial arm nestled comfortably between the larger Sagittarius and Perseus arms. This may be a fortunate location. Life in the middle of a grand spiral arm might be more difficult, with more intense radiation from the many hot, young stars and a higher rate of nearby supernova explosions. Our quiet little corner of the galaxy may have provided the long, stable period of peace that was necessary for complex life to emerge and evolve on our small blue world. But even in this quiet corner, we are not shielded from everything. The galaxy is humming with a constant, invisible rain of cosmic radiation. The space between the stars is not empty. It is filled with cosmic rays, which are high-energy particles, mostly protons and atomic nuclei, that have been accelerated to near the speed of light by violent events like supernova explosions. These particles stream through the galaxy in all directions, a constant invisible drizzle of energy. Every single second, several of these cosmic rays pass silently and harmlessly through your body. They carry with them the stories of distant cataclysmic events, the echoes of dying stars from the other side of the galaxy. We live and sleep within this gentle, energetic rain, a constant reminder of the galaxy's more violent and active nature. And sometimes that activity is on a scale that is almost too vast to comprehend. In 2010, astronomers using the Fermi Gamma Ray Space Telescope made a stunning discovery. Stretching for tens of thousands of light years above and below the galactic center, like two enormous ghostly balloons, are two vast lobes of high-energy light. These structures, known as the Fermi bubbles, glow in gamma rays and are completely invisible to our eyes. No one is entirely sure what created them. They may be the remnants of a powerful outburst from our central supermassive black hole, an eruption of energy that occurred millions of years ago when it consumed a large star or a gas cloud. Or they may be the result of a period of intense, rapid star formation in the galactic core. The combined winds and supernova explosions from thousands of massive stars blowing a colossal bubble in the intergalactic medium. Whatever their origin, these enormous ghostly structures drift silently over our galaxy. They are a monument to a more violent past, a pair of invisible signatures that tell us the heart of the Milky Way has not always been so quiet. They are the echoes of ancient fire, wrapped in a radiance that we can only see with our most sensitive instruments, hanging far, far above the familiar, peaceful stars we know. We have journeyed through the unseen architecture of our galaxy and witnessed the birth of stars in its cold, dark cradles. Now let us gently turn our focus inward, to our own small, precious place within this vast, swirling city of light. As you settle ever deeper into a state of rest, consider the quiet cosmic neighborhood that we call home. Chapter 7. Our Quiet Corner. The Milky Way is a place of dramatic contrasts, from the chaotic, high-energy environment of its core to the sparse, lonely expanses of its outer edge. Our home, the solar system, does not reside in one of these extremes. Instead, we find ourselves in a relatively calm, peaceful suburb of the galaxy. We do not live in one of the grand major spiral arms, which are bustling with the brilliant short-lived light of massive young stars and rocked by frequent supernova explosions. Our home is a smaller, more modest structure called the Orion Spur or Orion Arm, a partial arm nestled comfortably between the two larger Sagittarius and Perseus arms. It is not a particularly dense or spectacular region of the galaxy, but this very quietness may be the reason we are here. In the relative calm between the major galactic highways, the environment is more stable. The risk of a nearby supernova sterilizing a young planet is much lower. The gravitational jostling from passing stars is less frequent. This peaceful corner of the cosmos may have provided the long, uninterrupted period of stability that was necessary for the intricate, delicate process of life to emerge and evolve on our small blue world. From the great cosmic perspective, our galaxy is a place of breathtaking drama and radiant beauty. But here in our own quiet spur, we found just enough peace for complexity to unfold.
Our path through this neighborhood is also a special one. As we've learned, the spiral arms are patterns that move through the disk at a different speed than the individual stars. But there exists a special orbital distance from the galactic center known as the co-rotation radius, a place where the orbital speed of the stars almost perfectly matches the rotation speed of the spiral pattern itself. Our Sun orbits very close to this point of resonance. This means that for long periods of our history, we have been able to stay out of the major spiral arms. We are not constantly crossing these busy, chaotic regions. This gentle match in motion has likely shielded us from prolonged exposure to the intense radiation and gravitational disturbances found within the arms. We live, it seems, in a remarkably stable and protected neighborhood, shielded not by walls or by great distance, in a quiet cosmic eddy where the currents of the galaxy flow gently around us. Even our motion within this quiet neighborhood is not a simple, flat circle. As our sun orbits the galactic center, it also gently bobs up and down through the plane of the galaxy. Imagine a cork floating in a river, gently rising and falling as it is carried along by the current. Our solar system does the same, moving in a slow, graceful wave. It rises above the galactic plane, is gently pulled back down by the gravity of the disk, passes through to the other side, and then rises again. This vertical oscillation is a long and patient cycle, taking tens of millions of years to complete. Some researchers have even speculated whether this gentle bobbing motion might have consequences for life on Earth. They wonder if passing through the densest part of the galactic plane, where there is more gas, dust, and other stars, could slightly increase the risk of comet impacts or other disturbances. The evidence for this is not yet clear, but it is a beautiful and humbling thought. Even on our steady 250 million year journey around the galaxy's heart, we are not simply gliding, we are swaying softly and rhythmically through space. Our very own solar system is also tilted at a curious angle. The plane in which all the planets of our solar system orbit the Sun, known as the ecliptic plane, is not aligned with the plane of the galaxy. It is tilted at an angle of about 60 degrees. This is why, from our perspective on Earth, the hazy, star-rich band of the Milky Way arcs across our night sky at a steep angle. It is not parallel to the path that the Sun and planets traced across the heavens. We live in a small, tilted system, a little spinning top angled askew as it drifts through the larger, flatter sea of the galactic disk. This tilt gives us our beautiful, changing view of the galaxy throughout the year, a celestial panorama that shifts with the seasons. It is another quiet reminder that even within the grand ordered structures of the cosmos, there is room for beautiful and unique variations. We are part of the galaxy, but we are dancing to our own slightly different rhythm. And within this system, our Sun itself was almost certainly not born alone. Stars very rarely form in solitude. They are typically born in large groups, known as stellar clusters, all condensing from the same vast cloud of gas and dust. Our Sun was very likely part of such a family long ago. It would have shared its cosmic nursery with hundreds, perhaps thousands of sibling stars, all born from the same material, all of the same age. But over the billions of years since then, this birth cluster has long since dissolved. The gentle, persistent tidal forces of the galaxy and the gentle nudges from other passing stars and clouds have slowly pulled the family apart. The Sun's siblings have scattered across the galaxy, flung into different orbits, their ancient connection lost in the vast, shimmering crowd of stars. Even so, astronomers are now on a quest to find these long-lost relatives. Using vast stellar surveys, like the data from the European Space Agency's Gaia mission,
They are searching for stars that share the sun's exact age, motion through the galaxy, and most importantly, its unique chemical fingerprint. A few promising candidates have been identified, stars that may have once shared the same cradle as our own. If we could confirm their shared origin, they could tell us so much about the environment in which our sun and the early solar system were born. Our place in the galaxy, it seems, is not entirely solitary. Somewhere out there, shining in the distant darkness, the sun's ancient kin may still be quietly turning.
Beyond the bright, flat, and bustling spiral disk of the Milky Way, there lies another, much larger and more mysterious realm. It is a vast, spherical, and almost invisible structure known as the galactic halo. If the disk is a vibrant, luminous city, the halo is the immense, quiet, and ancient countryside that surrounds it for hundreds of thousands of light years in every direction. This halo is incredibly diffuse. The stars within it are spread so thinly that the space between them is immense. It contains only a small fraction of the galaxy's total stars, but it holds the majority of the galaxy's oldest inhabitants. These are the ancient, metal-poor stars, the living fossils we spoke of earlier that were born before the galactic disk had fully formed. They do not orbit in the neat, circular paths of the disk stars. Instead, they move in long, slow, elliptical, and highly tilted arcs, like a swarm of ancient bees circling a distant hive. The halo is also home to the galaxy's globular clusters. These are among the most beautiful and ancient objects in the universe. Imagine a compact, glittering sphere made of hundreds of thousands or even millions of tightly bound stars, all orbiting each other in a dense gravitational embrace. There are over 150 of these globular clusters known to orbit the Milky Way, drifting through the halo like ancient, majestic satellites. These clusters are incredibly old and stable, some more than 12 billion years old. Their stars are all metal-poor, having formed in that pristine early era of the cosmos. They are like cosmic time capsules, holding precious clues to how our galaxy first assembled, what smaller galaxies it may have consumed, and what the conditions were like in the universe's infancy. These quiet, golden spheres glowing patiently in the deep darkness of the halo are the galaxy's elders, the silent witnesses to its very beginning. But the most important and most mysterious component of the halo is not made of stars at all. The halo is the primary domain of dark matter. While the disk contains most of the galaxy's visible light, the halo contains most of its mass. This vast, invisible sphere of dark matter outweighs the entire luminous galaxy many times over. It is this unseen mass that provides the gravitational glue holding the whole structure together, allowing the outer stars to orbit at their surprisingly high speeds without flying off into space.
We do not see the halo in the same way we see the disk. It is a realm of deep quiet and profound darkness, punctuated only by the faint, ancient light of its sparse wandering stars. But it is, in a very real sense, the true foundation of the Milky Way. The bright, beautiful spiral that we call home is just the glowing sediment that has settled at the bottom of a much larger, much deeper, and almost entirely invisible gravitational well. The halo is the galaxy's outer memory, its quiet, dim, and massive soul, still in motion, still shaping what the Milky Way is and what it will become. And this halo is not empty. It is threaded with the ghostly remnants of the galaxy's past meals, the stellar streams from shredded dwarf galaxies, which we discussed earlier, are primarily found in the halo. As you drift through this vast, dark space, you would encounter these immense, arcing rivers of stars, some stretching for millions of light years. These are the last beautiful traces of galaxies that have long since been erased, their constituent stars now woven into the fabric of our own. The halo may also be home to countless rogue planets. These are not planets in the traditional sense, orbiting a parent star. They are cold, dark, and utterly alone, drifting through the immense darkness of the halo. Warmed only by the faint heat of their own cores, they float unseen, silent pilgrims on long, lonely paths through the great, empty spaces between the stars. The halo, it seems, is a place of ghosts, of ancient light, of unseen mass, and of lost and wandering worlds. Chapter 9. Our Cosmic Family. The Milky Way, as vast and magnificent as it is, does not exist in isolation. It is a member of a small, intimate cosmic family, a collection of more than 50 galaxies known as the Local Group. This is our galactic neighborhood, a small cluster of galaxies all drifting together through the much larger emptiness of intergalactic space. The Local Group spans a region more than 10 million light-years across, and all of its members are bound together, not by proximity alone, but by the gentle, persistent, and inescapable threads of their mutual gravity.
The galaxies of the Local Group are not, for the most part, flying apart as the rest of the universe expands. They are gravitationally bound. Their shared gravity has overcome the expansion of the universe on a local scale, and they are now engaged in a slow, majestic, and complex gravitational dance. Many of the smallest galaxies are in orbit around the two giants. The Magellanic Clouds, for example, the two bright, irregular galaxies visible from the southern hemisphere, are the largest and closest of the Milky Way's satellites. For many years, astronomers believed that these clouds were in a stable, long-term orbit around our galaxy, like moons around a planet. But recent, more precise measurements of their velocity have suggested a different, more exciting possibility.
The Magellanic Clouds may be newcomers, cosmic travelers on their very first close pass by the Milky Way, captured by our galaxy's gravity only recently in cosmic terms. Their arrival has had a profound effect, stirring up the gas in our outer halo, creating a vast ribbon of stripped gas called the Magellanic Stream that trails behind them, and perhaps even causing the warp in our galactic disk. We are witnessing a first encounter, a new chapter in the long story of our galaxy's growth. Over the immense timescales of the future, this cosmic family will likely grow even closer. The gravitational dance will continue. The smaller galaxies will continue to be absorbed by the larger ones. And as we know, the two great matriarchs of the group, the Milky Way and Andromeda, are on a slow, inevitable collision course. The future of the local group is one of quiet, graceful mergers, a slow condensation of its scattered members into one even grander structure. It is not a static arrangement of cosmic islands, but a gentle gravitational gathering, a family slowly being drawn closer by time, by inertia, and by the long, invisible reach of gravity. And this small family, the local group, is itself just one small part of a much, much larger structure. Our local group sits on the very edge of a colossal supercluster of galaxies known as the Virgo supercluster. And even this immense structure is just one filament in the vast web-like structure of the universe as a whole. As you rest here, allow your sense of scale to expand one more time. You are in a room, on a planet, in a solar system, in a quiet spur of a spiral galaxy, which is part of a small family of galaxies, which is itself just one small blossom on one branch of an unimaginably vast cosmic tree. Your connection to the cosmos is deep, profound, and inescapable. We will now let our experience of the Milky Way shift again, leaving the shores of our cosmic family and drifting back into the deep internal mysteries of the Milky Way itself. We have explored its visible structures and its tangible history. Now we will immerse ourselves in the invisible, the silent forces and ghostly particles that make up the true living environment of our galaxy. Allow your awareness to soften, to feel for the unseen currents that flow all around you, even now in the quiet of your room. Chapter 10: The Invisible Universe. The beautiful, shimmering light of the Milky Way, the light that has inspired poets and guided travelers for millennia, is only the very surface of its reality. The galaxy is humming with forces, threaded with fields, and filled with a sea of matter that we cannot see with our eyes. To truly understand our home, we must learn to perceive this invisible universe, the silent, omnipresent architecture that underlies everything we know. Imagine for a moment that you could see the galaxy's magnetic field. It would appear as a vast and intricate web of glowing lines weaving through the spiral arms, stretching high above and below the galactic disk, and threading through the dark clouds of interstellar gas. This field is incredibly weak by earthly standards, far weaker than the magnet on your refrigerator. But over the immense distances of the galaxy, its influence is profound. It acts as an invisible current, guiding the flow of charged particles like cosmic rays on their long journeys across the void. It helps to shape the delicate filamentary structures within molecular clouds, perhaps even influencing how and where new stars are born. The galaxy does not just glow with light, it breathes with a quiet, pervasive magnetism, a subtle, invisible pulse running through its very bones. The space between the stars, which appears to our eyes as a perfect empty blackness, is also an illusion. This space is filled with the interstellar medium, a thin, turbulent sea of gas, dust, and plasma. While it is a far better vacuum than anything we can create on Earth, it is not empty, and it is not still.
The interstellar medium is a dynamic and complex environment. It is stirred by the shock waves from ancient supernovae, which carve out vast, hot bubbles hundreds of light years across. It is sculpted by the powerful winds of young, massive stars. It forms cold, dense clouds that can collapse into new stars, and it weaves itself into long, tenuous filaments that trace the lines of the magnetic field. The space between the stars is not a void. It is a shifting, swirling, and ever-changing fabric, the quiet, raw material from which galaxies evolve and life eventually can begin. Through this invisible medium, silent messengers are constantly streaming. Every second, trillions of ghostly particles called neutrinos pass through your body, through this room, through the entire planet, as if it were not there at all. These incredibly light, almost massless particles are born in the nuclear furnaces at the hearts of stars, in the cataclysmic explosions of supernovae, and in the collisions of cosmic rays with atoms in space. They are so unreactive that they can travel across the entire galaxy without being stopped or deflected. They are the galaxy's whispers, carrying information directly from the fiery cores of stars and the hearts of cosmic cataclysms. Special observatories buried deep underground to shield them from all other radiation wait patiently in the darkness, hoping to catch the faint, fleeting flash of light from a single, rare neutrino collision, a tiny message from the galaxy's hidden engine. And there is another, even more profound tremor that constantly ripples through our galaxy. These
are gravitational waves, ripples not in matter, but in the very fabric of space-time itself. When two incredibly massive objects, like black holes or neutron stars, spiral together and collide somewhere in the distant universe, they send out waves of gravitational energy that travel outward at the speed of light. As these waves pass through our galaxy, through our solar system, through you, they stretch and compress space by an amount so tiny it is almost immeasurable. But we have built instruments sensitive enough to detect them. We have felt the echo of black holes merging 1 billion light-years away. Even now, as you rest, the stage of reality itself is gently, silently quivering, carrying the news of ancient cosmic dramas from across the universe. The Milky Way we see is just the luminous foam on the surface of a much deeper, invisible ocean. It is an ocean of dark matter, of magnetic fields, of ghostly particles, and of rippling space-time. To truly know our home is to appreciate this profound and beautiful invisibility, the quiet, unseen forces that hold it all together. Chapter 11. The Fossils of Creation. Our journey through the Milky Way has been a journey through space, but it has also been a journey through time. The galaxy is a great cosmic archive, preserving in its light and in its motion the story of its own long and beautiful history. To read this history, we must seek out the galaxy's oldest inhabitants, the ancient survivors from a time long past. We must become cosmic archaeologists, digging not in the dust of the earth, but in the faint, ancient light of the halo. These are the fossils of creation. High above the bright, bustling plain of the galactic disk, in the vast, dark expanse of the halo, drift the hyper-metal-poor stars. As we have learned, these are the true elders of the galaxy. Their atmospheres contain almost no elements heavier than hydrogen and helium, a pristine chemical signature that tells us they were born in the universe's infancy over 13 billion years ago. They are the survivors of the very first or second generation of stars, formed from the clean, unenriched gas of the early cosmos.
These stars are typically small, cool, and faint, glowing with a soft red light. They have been burning quietly and patiently for an immense stretch of time, long before the Milky Way had even settled into its beautiful spiral shape. To find and study one of these stars is to open a direct window onto the past. In their faint, steady light, we can read the chemical conditions of a universe that was still in the process of becoming. They are not just stars, they are living relics, glowing, gravitationally bound signatures from the universe's earliest dawn.
In this same ancient realm, we find other, more ghostly fossils. These are the ancient white dwarfs. A white dwarf is the cooling, collapsed core of a star like our sun after it has exhausted its nuclear fuel. It is the dense, fading ember left behind after a star's long life. Astronomers have found white dwarfs in the halo that are incredibly old, so old that the stars they came from must have lived and died before the galaxy's thin disk had even formed. These ancient remnants are now incredibly faint and difficult to find. They have been cooling for billions of years, slowly radiating away their residual heat, fading into the deep blackness of the halo. Each one is a quiet monument, a stellar ghost that tells the story of a sun that shone in a much younger, much different galaxy. They are the silent, fading memories of the Milky Way's first generation of stars. The bright disk may be where the galaxy lives now, but the halo remembers a time much, much further back. And of course, there are the most beautiful fossils of all, the globular clusters. As we have seen, these are the tight, glittering spherical cities of hundreds of thousands of ancient stars, all bound together by their mutual gravity. They are like self-contained miniature fossil galaxies orbiting our own. The stars within a single globular cluster were all born at the same time from the same cloud of gas over 12 billion years ago. Because they are so old and have remained so isolated from the gas-rich disk, they have preserved the chemical conditions of the early universe like a perfect sample in a cosmic museum. By studying these clusters, we can understand how the first stars formed, how they were organized, and how these ancient building blocks were eventually incorporated into the grand structure of the Milky Way. When you see an image of a globular cluster, you are not just looking at a beautiful collection of stars. You are looking at a fragment of the past, a surviving piece of the primordial cloud from which our galaxy was born. Still shining, still orbiting, a living testament to the deep and beautiful history of the cosmos.
This cosmic archaeology tells us a profound story. The Milky Way was not born in a single grand event. It was built piece by piece over billions of years. It assembled itself from smaller structures, from ancient star clusters, from primordial gas clouds, and from the captured light of smaller satellite galaxies. Its history is not a single linear narrative, but a rich and complex tapestry, woven from the threads of countless other older stories. The evidence for this long and gentle process of creation is still here, all around us, shining quietly in the dark,
waiting for us to read its ancient light. Conclusion: the river of starlight. And so, our long and gentle journey through the Milky Way comes to a soft and quiet close. We have drifted on the currents of starlight, from the chaotic, beautiful nurseries where new suns are born, to the ancient, silent halo where the ghosts of the galaxy's past still wander. We have felt the immense, invisible presence of dark matter holding us all in its gentle, gravitational embrace. And we have peered into the enigmatic, sleeping heart of the supermassive black hole at the galaxy's core. We have learned that our serene home is a place of ancient collisions, a beautiful structure built from the consumed light of other, smaller worlds. We have realized that we are in constant, sweeping motion, part of a grand, silent dance that takes hundreds of millions of years to complete. We have seen that the galaxy is a place of profound and beautiful recycling, where the very atoms that make up our world and our bodies were forged in the hearts of stars that died long ago. And now, as you lie here on the edge of sleep, allow yourself to feel this profound connection. You are not just an observer of this galaxy. You are a part of it. The iron in your blood, the calcium in your bones, the oxygen that fills your lungs with every slow, deep breath, all of it is stardust. You are a small, temporary, but exquisitely beautiful expression of the Milky Way's long and luminous story. As you rest tonight, the galaxy continues its silent turning dance. New stars are igniting in distant, dusty clouds. Light that began its journey thousands of years ago is just now arriving at our small blue planet. The entire vast structure is breathing, evolving, and quietly, gracefully becoming. You are floating within it, safe and secure. A small, precious warmth in the vast, cool darkness, resting peacefully in the gentle spiral arm of a quiet, radiant, and wondrous sea of stars. Let this river of starlight carry you now into a deep and peaceful rest. Sleep well and dream softly. Good night.